So in this video, we're going to graph rational functions that have slant asymptotes, okay? Think back to when we were talking about horizontal asymptotes. We won't have a horizontal asymptote if the degree of the numerator is greater than the degree of the denominator, okay? Now, a slant asymptote is going to occur in one specific instance. So that's going to occur when the degree of the numerator is one more than the degree of the denominator, okay? If it's more than that, you're not going to have a slant asymptote. At most, you can only have one slant asymptote, okay? So in order to find that, we're going to use division, either long or synthetic division, to find the equation of that asymptote. And it's always going to be just the quotient. The remainder, when we do that division, is irrelevant. We're just looking for the quotient part of the answer, okay? So let's look at number one here. We've got r of x equals x squared minus 4x minus 5 over x minus 3. So as always, the first thing we want to do is factor, okay? That's going to allow us to find the intercepts. It's going to see, it's going to allow us to see if we can cancel anything out, to find removable discontinuity, okay? And it's also going to allow us to make sure we know what the vertical asymptotes are, okay? So just looking at this denominator, nothing cancels out. So my vertical asymptote is going to be at x equals 3, okay? Now, I can find the x intercepts by plugging in, by setting these factors equal to 0, okay? So one of my x intercepts will be at 5, and the other will be at -1, okay? Now the y-intercept, I'm actually going to go back to the original function. If we plug in 0 for all those, we're left with -5 over -3, or 5/3, okay? So these 3 points are very helpful when we're going through the graphing process, okay? Now, remember, degree of the numerator is 2, degree of the denominator is 1. That's 1 more than the denominator, so we are going to have a slant asymptote. Now, because my denominator is a linear piece here with a leading coefficient of 1, I can use synthetic division. That's easier, quicker than doing long division, okay? So the value here that makes this 0 is 3, so that goes out front. And then the coefficient of x squared is 1, coefficient of x is -4, and the constant is -5, okay? So using synthetic division, I'm going to bring down the 1. Okay, and now I'm going to multiply 3 times 1, which gives me 3. When I combine these, I get -1. I'm going to multiply and get -3, combine those and get -8. Now, like we set up here in the notes, okay, the remainder is irrelevant. So I'm going to cancel out, we've got x minus 1 and then -8 over x minus 3. The remainder is irrelevant, so I'm going to cancel out those 2 remainders. Okay, so this is the only part I'm interested in when I'm finding the slant asymptote. So based on this, my equation for my slant asymptote is going to be y equals x minus 1, okay? So you're going to graph your vertical asymptote, you're going to graph this slant asymptote, and then that's going to help us graph this rational function, okay? Just like before, we need to know the behavior approaching the vertical asymptote from both sides, okay? So we want to approach this 3 from the left and from the right, okay? So let's start out coming from the left. If we plug in 2 for x into either the original function or the simplified one here, we're going to get a y value of 9, okay? Let's plug in 2.9. We want to get closer and closer to this vertical asymptote. So let's plug in 2.9. When we do that, we get a value of 81.9, okay? Notice, still positive, getting larger and larger. So what we say, as x approaches 3 from the left, y is going to approach positive infinity, okay? Now we want to come at that vertical asymptote from the right. So let's plug in 4. When we do that, we get -5 for our value, okay? Let's get a little bit closer to 3. Let's plug in 3.1, and I'm going to get a -77.9, okay? So we keep getting smaller and smaller and smaller. So we say, as x approaches 3 from the right, y is approaching -infinity, okay? Now, unlike with the horizontal asymptotes, we're not going to plug in like we did before, like the -1000 or the very large numbers that are both negative and positive, okay? Let's just plug in a value to see what we get. So something that's going to be on our graph here, I chose to plug in -10, okay? When I plug in -10, I get -10.38, okay? So I'm going to plot that point here in a second when we graph this. On the positive side, let's plug in 10. And when I plug in 10 to the function, I get 7.86, okay? The graph will approach that slant asymptote on the extremes just like when we were graphing with horizontal asymptotes, okay? So we're going to use this table of values and the information that we've got here to graph this function. So let's do that graph now. Okay, so we're going to graph this function now. We had a vertical asymptote at x equals 3, so I've drawn that already. The slant asymptote we found was at y equals x minus 1. So you can use just basic slope-intercept form, y-intercept at -1, and then a +1 slope, okay? So this is going to be our slant asymptote. Now, we found two x-intercepts. One was at -1, okay, and one was at +5 here, okay? We had a y-intercept at 5/3, okay? We plotted a few other, points in our table values. So we had 2, 9 on the graph, which is going to be up here. And then we had -10 and then -10.38. So it's going to be right down here. Okay. On the right side, we had a point at 4, -5. So right 4 down 1, 2, 3, 4, 5. Okay. We also had a point at 10 and then 7.86. So up 1, 2, 3, 4, 5, 6, 7. Almost to there. Okay, almost to 8, but not quite. Okay. Now, we knew coming from the left of the vertical asymptote, we were approaching positive infinity. So I know these points are going to go right through there like that. Okay. Coming from the right of the vertical asymptote, we were coming down toward negative infinity there. Okay. And the end behavior is always going to approach this slant asymptote. So I know I'm going to come like this. And then down here, I'm going to go to this point, -10, -10 and 3, or 10.38, okay? So that's going to be the graph of that rational function with a slant asymptote.